Good morning, and welcome to today's webinar on general safety and health risks, brought to you by the USF SafetyFlorida Consultation Program, the USF OSHA Training Institute Education Center, and the Sunshine ERC. This presentation is not a standard or regulation and does not create new legal obligations. It includes recommendations and descriptions of mandatory OSHA safety and health standards. The Occupational Safety and Health Act requires employers to comply with these standards and to provide a workplace free from recognized hazards likely to cause death or serious harm. The webinar will run for 90 minutes, including about 10 to 20 minutes at the end for Q&A. You are in listen-only mode, but feel free to submit questions in the Q&A box at any time. We'll address them after the presentation. If you experience technical issues, please contact your department's IT help desk. Also, remember to complete the short survey at the end. Your feedback helps us improve future webinars. I'm Thalia Barber, your moderator. Alex Fernandez will also join me to help facilitate today's session. Now let's meet our presenters. Dr. Clarence Rodriguez is a senior safety and health consultant and supervisor with the OSHA Consultation Program at the University of South Florida's College of Public Health. He also serves as an adjunct engineering professor in the Industrial and Management Systems Engineering Department, an independent EHS consultant and co-author of the Commercial Aviation Safety Textbook, McGraw-Hill 7th edition. He has held leadership and faculty roles at institutions including Khalifa University in Abu Dhabi, Embry-Riddle Aeronautical University, Indiana University of Pennsylvania, the University of Pennsylvania, and the College of New Jersey. He also served as worldwide engineering manager for the Campbell Soup Company, overseeing ergonomics and system safety across more than 130 global operations. Dr. Rodriguez has consulted internationally across academia, industry, and government, and has delivered numerous invited presentations at the national and international conferences. Next, we have Mr. Merrill M. Finger, a safety and health consultant with the OSHA Consultation Program at the University of South Florida's College of Public Health. He brings valuable experience from his previous role with the New York State Department of Labor, where he spent 2 years supporting workplace safety initiatives. Before that, Merrill worked in private industry in environmental health and safety, as well as in chemical laboratory operations. He holds a master's degree in public health from the Florida A&M University. A bit about our host. USF SafetyFlorida is Florida's official OSHA consultation program, offering free, confidential services to help small and medium-sized businesses identify hazards, improve safety practices, and reduce workplace injuries. The USF OSHA Training Institute Education Center delivers OSHA-authorized training across the Southeast to include Florida, Georgia, and the Carolinas, equipping professionals with the knowledge to maintain safe and compliant workplaces. Let's get started. I'll now turn the webinar over to Merrill M. Finger to begin today's presentation.
Thank you, Thalia. So today we're going to go over some objectives here, the fundamentals of risk assessment, the qualitative methods of evaluating job-related risk, overview of physical, chemical, biological, and ergonomic hazards, using sample job scenarios to rank workplace risk, strategies for applying risk levels to safety decision-making. Identifying common workplace hazards. And every workplace is going to be different, so every workplace may have different hazards. Types of hazards are physical, chemical, biological, and ergonomic. Some of the physical hazards that are in the workplace are electrical, fire, noise, falls, and heat. Chemical hazards in the workplace are corrosive, reactive, carcinogens, and toxic. Biological hazards, bloodborne pathogens, mold, fungi, waste, and bacteria. And ergonomic hazards, we have material handling, lifting, and you'll hear later in our presentation, Dr. Rodriguez is going to describe some of the different techniques and evaluations. Repetitive motion. There's ways of evaluating these. Poor workstation design. bad posture, and vibration all could lead to injuries due to ergonomics. And now I'm going to pass it over to my colleague, Dr. Rodriguez, and he's going to go over further about the risk and management. Thank you.
Welcome, ladies and gentlemen. As you can see there, Photoshop can really do a good job on someone, all right? So keep that in mind. So on that humorous note, let's get on with business and move on to our presentation today, which is going to be implementing risk assessment. Now, before we get into the business, we've got to talk about some of the objectives or the bullet points that we are going to attempt and cover. And we're going to start off with, of course, identifying the hazards, which my colleague Meryl has just gone through in terms of recapping all of the hazards you're likely to find in the workplace. And we're going to then take it one step further by introducing or talking about who or what is at risk, personal equipment, environment, reputation. We're going to talk more about that. We're then going to talk about the aspect of quantifying the risk, and we see the importance of why we do what we do and why we need to quantify. We will rank risks, hazards by the levels of risk. And I slipped up over there. I said we rank hazards. No, we rank the risks of the hazards. And sometimes we mix up between risk and hazards and severity. And hopefully we will clarify that for you. The various components of a risk. Implementing controls, that's why we, of course, do this to begin with, because we want to be able to implement controls and effective controls, of course, at that. And then last but not the least, we document and review regularly. This is important that we do it because we need to know if our controls are working and if we are meeting our objectives and how we go about fixing those. We don't have a roadmap. We don't know how we're going to, whether we're going to achieve our objectives or not. All right. And this is part of implementing risk assessment. Now, this is a process, risk management. As you can see, it's a continuous loop, and you've probably heard about this before in terms of it's a continuous feedback loop of managing risks in which you identify the risks, or the hazards, which Meryl has just spoken about. Then we start the evaluation, and that's what most of this seminar is going to be about, is evaluating, measuring, and quantifying these risks. Then once you evaluate them, we, of course, prioritize them from high to low, because that's where we can then start allocating capital, because resources are not infinite, and we have to prioritize. So that's why we do it. Then we control. We're looking at control and this concept that we're going to talk about, which you probably already know, but that never hurts to re-emphasize this. As low as reasonably practicable. We've got to understand that because we are always handling or dealing with risk in life, whether it's occupationally or non-occupationally. But the bottom line is we are trying to control and manage our risk to levels that are low as reasonably practicable. We talk about zero. There's no really concept of zero risk, especially on the occupational side of the house, because the only way you have zero risk for occupational injuries is do no work. And we know that ain't going to happen. All right. So given the fact that we're going to work, we're going to have an occupation, how do we manage our risks to the lowest practicable levels? All right. Then, of course, we've got to accept it because there's always residual risk that occurs. The only question becomes is how much of residual risk there is they're willing to accept, and how can we manage that residual risk? And we'll get into a little bit about that too. Okay. And then it's the verification process. Are we doing what we said we are doing? Are our controls working? Is our projects delivering on what it said it would deliver? I remember one of my first jobs when I went into Campbell's was I was asked by senior management to go evaluate all of our productivity projects that were allegedly supposed to deliver 20-25% on our margins. Our hurdle rate at that time was 20%, and we wanted to make sure that it was delivering on what they said it was delivering. So I had to go back and make sure and see if, in fact, the numbers were being met. And if not, why not, right? So it's the verification process, and that's important, okay? And this is continuous process and how we manage risk. Now, why we measure risk? Management by measurement. If anything, slide is among the most important what you need to take back or include in your portfolio. Management by measurement. Because we cannot manage or we cannot measure. We've got to be able to understand that. Then, of course, the next thing comes up is that what do you manage? All right, how do you select the variables? You got to measure what matters. And we will call it the targets of interest. What are we trying to address? Quality, product defects. If you look at safety, you're looking at incident rates, severity rates. Those are what we're trying to address. Those are what matters. Access, excellence. When we talk about access for risk. Right now, there's an issue in the Pentagon where reporters having access to information. There's a security risk in terms of who gets what kinds of information. So you might want to, that might be a target that you are measuring against, right? Excellence. What do you consider as excellence? All right. How do you define what excellence is? And then, of course, with time, these measures might change. So, for instance, if you achieved your quality goals, let's say 1% defect rate is acceptable, you're going to say, okay, now let's move on to the next. All right, improve our margins, our hurdle rates. So measure what matters, because that's what management is looking at all the time. Right? It's all about the numbers. And if you're a publicly traded company, you're trying to answer to your shareholders. If you're not, you're still trying to answer to your investors, right? The investors may be 2 or 3 individuals. If you're a small business, medium-sized business, it all depends, all right? But you're always accountable for individuals that are invested in your business. Quantification is necessary in terms of, especially when you're trying to reduce the risk. When I say I have reduced risk a lot, you haven't told me anything when you say a lot, but you've got to add to that, I've reduced risk by 10%, by 30%, by 40%. Now you're telling me something. All right. So quantification is necessary. Now, to begin with, before we get any further, we have to get this out of the way in terms of risk, defining of risk. It's a combination of probability and severity. And note, we're talking probability multiplied by severity. All right. Now, you're going to see some schools of thought that's going to have risk equals probability plus severity. If that takes place, you got to keep in mind that if you're putting the addition, you can reach a scenario where you can have 0 probability coupled with a severity. All right, which doesn't really make sense, because here you're talking about a risk with having no chance of happening, but here you do have a severity attached to it in terms of losses, dollars, whatever, right? If you use the plus sign, probability plus severity. Now, that using the plus additive model does work. It has its uses. It has been used, but it's based on the function or assumption that a hazard will materialize. Given that, then how do we quantify the risk, all right? But for the purposes of our discussion over here, and in general, when you talk about risk, it's probability times severity. Now, there are other multipliers too that might come in terms of costs and other details, which of course is beyond the scope of this presentation, but keep that in mind, all right, in terms of risk being probability times severity. What is probability? The chances of an event taking place per unit of time. And remember, you have to define the unit of time, because eventually things will happen, right? You have equipment that works long enough, it will fail. All right. We humans, we live long enough, we will fail. We will go. So you got to define the time domain, right? Usually for capital equipment or big plants like oil and gas facilities, it's 25 years is the operating period. For aircraft, it'll be 20 years without super maintenance or extensions. So you have to define the time domain. But this is the chance of an event occurring, a negative event, per unit of time. All right. By the way, we can even have positive events taking place too per unit of time. All right. And then, of course, we have severity. Given that the event takes place, given that you have a lost time incident, how many days have you lost? That'll be the severity. or what does it cost? What is the workers' comp cost per time or per unit or per incident that has occurred? All right, that's the severity. And when you multiply the two out and you harmonize the units, you get risk as expected loss per unit of time or activity. These are what the insurance companies use all the time. Your insurance loss carriers, this is what they're looking at in terms of how they define risk. And of course, your management too. It's basically the losses. You're trying to minimize your losses. All right. Okay, in terms of the risk assessment techniques, we have the qualitative, we have the quantitative, and we have the hybrid. I know as part of our objectives, we only mentioned qualitative, but at USF and in the OSHA consultation program, we deliver more than what we just say. All right. So we're also going to give you some quantitative, and we're also going to give you some hybrid. All right. So hang in there. So when we talk about sampling assessment techniques, there's a whole bunch of them, hundreds. What we're going to talk about, just a few, we're going to talk about over here in terms of the NIOS lifting equation and ruler. We're not going to talk to you about how we actually use these techniques, but we're going to talk about the end results of the techniques and how we apply that risk. All right. So we're just going to talk about these two over here to give you an example or a sense of how you manage risk. Then my colleague will going to talk about task analysis. Merrill, he's going to mention JSA and JHA. We're going to talk about that. Right? But as you can see, there's a whole bunch of other techniques. If you look at like fault tree analysis, these are the more advanced techniques, system safety analysis techniques, failure modes effects analysis, fault tree analysis. These are some of the techniques that I use in the aviation, aerospace business, oil and gas business, petrochemical businesses, wherein you have critical infrastructures where the severity can be very catastrophic. The probabilities of occurrence of these events are small, like in the nuclear business also. But if they do occur, it's highly catastrophic. So you use more advanced and quantitative techniques. Of course, the fault tree analysis being the biggest of them all, which you can do qualitative and quantitative. Then, of course, there's hazard and operability analysis based on your PSM standard. All right. OSHA 19-119, that's used a lot in the petrochemical and oil and gas business. But the bottom line is, as you can see, there are many others. What you need for your business is a function of what you do in your business. So if we do get asked later on questions on what techniques should we use, well, we've got to understand what you do. What's your business, all right? Come to your facility, take a look at things, see what we do, and then offer advice on what techniques you will really need, all right? So anyways, now, over here in terms of the calibration of the matrix. Now, what do you take away from this slide? Okay. By the way, to begin with, this matrix, you may have heard of the risk matrix. This matrix was introduced and used many moons ago by our Department of Defense. They were the folks that first helped set this up, the concept of this, and now we keep using it as the years progress. Now, if you take a look at this, there are targets of interest. And by the way, each matrix has to be calibrated to your levels of risk. Each business has its own risk matrix, all right? Or should have it anyways. Now look at the targets of interest. They look at the personal, they look at equipment loss, downtime, product losses. These are the targets of interest. Here's what they're trying to, measure or guard against. Now, within these targets of interest, they have levels of risk acceptance. So for them, catastrophic is death. One death is catastrophic, all right? Severe injuries will be critical. Minor injuries will be marginal. No injuries or illnesses, negligible. Very small probabilities of occurrence. Now, in terms of equipment loss, for them, the Department of Defense that uses our tax dollars, 1 million, they've set any loss exceeding 1 million will be considered catastrophic. For small businesses, that might be 5,000. For you and me personally, it might be $100. All right. So all depends on how you calibrate it to your risk. Similar concept can be applied to downtime and to product loss. All right. So these are the targets of interest. Here you're setting up what levels of risk you're willing to accept. Now, that being said, and of course, you can have on the environment too, right, in terms of the loss effects. And as I said, there are many targets of interest that you can select. Now you get into the probability. What are the chances of these things taking place? Over here, you can either say, qualitatively, you can say A, B, C, D, E, frequent, probable, occasional, but you can also attach a value to it. So 1 in 10, or 1 in 100, 1 in 100, 1 in a million. All right. It's how you phase this in. All right. Exposure intervals. It's up to you in terms of how you set this up. A probability of occurrences. All right. So you can either go quantitative on this or you can go qualitative. Now, in terms of probabilities of failure, if you're looking at hardware failure, every part failure, there are databases that exist that you can get hardware failure from. So for instance, if let's say you're specing a production system or your pipeline system, you get the failure rate of pipes based on their material, whether it's cast iron or HDP or whatever, or failure rate for valves, whether it's a pressure relief valve or different types of valves, you get failure rates on those. So which actually do exist. All right. So you can actually have those failure rates, or you can develop your own failure rates, and the place that you get it is from your maintenance department, because the maintenance folks get to see things that are, break down and fail and whatever, and they know what's going on. All right. So that's how you get your failure rate data or probabilities of occurrence of failure, and you can get that, from your system. So either from you developing your own, or there are databases out there, and you can do a comparative analysis of how similar your business is to the data that's available out there. Okay. Now it gets a little more detailed, but it's beyond the scope of this presentation. But keep in mind, these are how things work. All right. Then once you get all of that together, you put it nicely in a little colorful matrix over here in terms of, and we say that something that is frequent and catastrophic, that's in this cell over here in 1, and there could be several hazards that meet this category. We call it a 1, a red. Red is dangerous. We got to fix it, right? So all of these in the red, we say, okay, reduce probability or severity or both, or just decline the operation. Don't do what you have to do because it's too hazardous to deal with it. Now, it's easier said than done, because there are some businesses, like for instance, if you're pulling oil out of the ground, that's your core business, right? You cannot outsource that, or you cannot stop making that, right? So you got to then start managing your risk, all right? So it's not feasible to discontinue the business, but of course there are controls that you have to apply in place, engineering controls and all of those kinds of controls. And then, of course, you have lesser values, risk mentioned the orange, the yellow, and the green. And of course, when you say green, means it's acceptable levels of risk. Now, remember, just because it's in the green doesn't mean it's acceptable. There is no chances of it happening. All it means is that the risks are acceptable and we can continue business. But always keep in mind that these acceptable risks at this point in time may not be acceptable down the road. All right? So keep that in mind. Regulations change. The we're talking about the H2S, hydrogen sulfide regulation. It's at one time its levels were 10 and 15 10 as TWAs and 15 stells were the limits. Over time, the ACGIH narrowed or had the limits more stringent, right, to 5 and 1. So bottom line is what I'm trying to say is that regulations change, technology changes, risk changes, all right, severity of risk changes. So for instance, when you're looking at insurance costs, while the incidences have reduced, the costs for these incidents have gone up, all right? So the risk shift. So keep that in mind. Just because it's green now doesn't mean it has to be green in the future, all right? So anyway, that's where that is concerned. Now, here's one example, and this, of course, in the oil and gas business, how these guys manage their risk. They just have 3 zones. There's the high risk, there's the medium, ALARP, as low as reasonably practicable, and of course, there's the green section, which is allowable. Now, I say this is semi-quantitative because, as you can see, the probability values over here have numbers, whereas the severity do not have numbers. They're just qualified over here. Now, in the background, there are numbers that actually support these assets or support these categories. But for the matrix purposes, for operationally in the field, this is the matrix that basically that they use, right? And in that case, if it's high risk, you do certain things. If it's medium risk, you do certain things. And of course, low risk, you continue business and, continue to, corrections may be made as resources allow. So you're continuously improving your process, although it's in the green zone, all right? Now let's take an example, a real example of what you might likely face. Now, if you keep data, if you're required to keep OSHA 300 log data, if your business meets that criteria, Or if it doesn't meet that criteria, but you are keeping near misses or incidences or whatever, we can use that data. We can make use of that data. Now that you've got the numbers, let's see how we manage those numbers or make sense of those numbers. So given that fact, this one of a sample from a company that had these three departments, or rather four departments. And if they just looked at the pure number of injuries, you can see over here that Department A has only 5 injuries and Department D has 20 injuries. And you might say, ha ha, Department D is a problem. We got to fix it. But once again, we say, hold on just a minute, shall we? Because if we wait for the next slide, as you can see over here, we have now Department A has 50% of injuries of the folks that are injured, whereas D has only 5%. And why is that? Because by the law of statistics, by sheer statistics, the more workers you have, the more injuries you're likely to expect. But the problem is, if you have more injuries than what you're supposed to get by your statistics or what they dictate, then that becomes an issue. So as you can see over here, once you standardize the data or normalize the data by the number of the workers worked, you can see that Department A now is of a higher risk than Department D. All right. And now we've just talked probability side of it. We haven't included the severity, the cost. What if the cost of the Department D, although percentage-wise on the proportion count is only 5, but what if each of these injuries costs $100,000? Whereas in the Department A, each of those injuries only cost $10. All right. So we don't know the whole story. All right. So till we know the whole story of, the costs or other factors involved, all right, then we have to go with what we have as of right now. So that's the next slide. Here we bring in the severity. All right. We bring that in. And let's see what this slide entails. Now, the incident rate, this is the standard calculation we use that OSHA uses, or you're supposed to use for calculating your incident rates for your OSHA logs, if you're required to keep them. Per 200,000 hours, 100 workers working 50 weeks a year, 40 hours a week. All right. So you have your incident rate. All right. And we have the incident rate where we have two departments, aircraft riveting and wing assembly, going back to my days in the aviation aerospace business. And we calculate an incident rate over here for these two. And then, of course, here we're using severity rate, not the number of lost day cases, but the actual lost days, lost work days. I'm using them because I want to increase the awareness, so make the numbers larger, all right, in terms of not fixing the data, but using the right kind of data to increase the awareness. So I'm using lost days, right? And for lost days, of course, I just crank it into this equation here, and I get a severity rate. So now I have an incident rate. By the way, the incident rate is a proxy for the probability of occurrence. Incident rate. It's a way of telling you, at what rate your incidents are going to occur, the probabilities. And this is the severity. So now what happens is over here, as you can see, these numbers are different. These numbers are different. So which is a higher risk? Well, if I multiply these two numbers, 35.7 and 119, it happens to be less than the product of 12.7 and 380. So therefore, if I were to have a risk column over here, which I should remember in my next presentation to have a risk column over here included, you will see that wing assembly has a higher number over here than aircraft riveting. And so if we have to choose between these two departments to address the issues, I would go with wing assembly as opposed to aircraft riveting. Okay. Now, it could well be that aircraft riveting is too high in itself. All right. So I might just decide to do both. But what if now I have 10 different departments using the same logic? Now you see where I'm coming from. Depending on the capital and the resources you have, you can then start allocating them to your departments that have the highest, working with the departments that have the highest risk, than working to the lowest risk one. Over here, let's say you have material handling jobs. The standard equation used for material handling job, the Nash equation, is the recommended weight limit. All right. So you crank in all these values over here. Once again, our OSHA Technical Institute, which is our sister division at the USF, does training. All right. and ergonomics is one of the areas and domains that they cover, and they get into material handling, repetitive motion, and all those kinds of analysis techniques. It's a 3-day course, of course. So the details of that can always be figured out later on, but we are trying to use the end results over here and try to make sense and analyze it for our presentation. Then we come up with something as the lifting index, the load that you're actually lifting compared to the load that you're supposed to lift. All right. So the task that you're actually lifting is, let's say, 20 pounds, and your recommended weight limit is 10 pounds, then your lifting index is 2. All right. So that's how that works. Now, if your lifting index is greater than 3, so let's say you're lifting 30 pounds and your recommended is 10, if it's equal or greater, it says greater over here, but 3 is pushing it. But let's say it's 30.1 pounds, right? You're lifting 30.1 kgs if you're using the SI units, right? It's unacceptable, and we got to fix it, all right? And if it's less than a 1, it's low and it's acceptable. Now keep this in mind. Just because this is less than 1, what this means is, doesn't mean you won't get injured if you are lifting at an index that's less than 1. All it means is that the risk of you getting injured by lifting at the levels less than 1, lifting index less than 1, is acceptable, and we can go forward. Doesn't mean you won't get injured. Similarly, over here, it says just because you're lifting at a limit greater than 3 doesn't necessarily mean you get injured, but the risks of you getting injured are so high that we're willing to accept it. So keep that in mind, what these numbers actually mean. In and of itself, calculating these values may not mean very much, but in relative risk terms, that's where you're looking at in terms of how you address them, right? Now, this is on the material handling side of the house. Now, over here, what if it's between 1 and 3? Above 3 and below 1, straightforward, no big deal. But between 1 and 3 now, how do you manage it? That's where you start calculating individual values for the different jobs you have, and then going from the highest score to the lowest score and addressing them. Okay. Now this is repetitive motion jobs. I know this is a crowded slide with a lot of pictures and diagrams, but that's not the intent. Don't even pay attention to all of these. What you do have to pay attention to, and by the way, how you actually work through these sheets is covered in the classes and the course that I just talked about a few minutes ago. But what we're really concerned about once you combine all of these values of upper extremity assessment, this table over here, you really have to concern yourself with. Higher numbers are bad. Lower numbers are good. Where do you cut off? 3, 4, 5, usually in the 7s, is very similar to greater than 3 on the lifting equation, so you want to get rid of them. 1, 2s, maybe even 3s are acceptable, all right? But the 4s and 5s, you got to try and measure. So this is the table you boil down to, which you manage your risk for repetitive motion jobs for this type of analysis. Okay? So that's where you do this kind of work. So in risk management summary, you assess the probability, you estimate the severity, calculate the risk, rank risk from high to low, allocate resources based on capital availability and risk tolerance. Great. Now, once you've gotten to that, let's figure out what happens to risk reduction precedences. You've heard of the risk reduction precedence strategy, right? Engineering is on top and PP is below, and there's a hierarchy, right? Here's where we're going to apply the hierarchy, but use the risk equation. So designing and engineering. This reduces both severity and probability. So you can design a process using the chemistry and physics of things to design a process that is safe, inherently safe, known as inherent plant design, where you don't require any bells and whistles of pressure relief valves and all of those other issues operating at temperatures below auto ignition and materials. And so you do design and engineering. So severity and probability gets reduced. Then you come to safety devices. Let's say something goes bad in your processes and pressure exceeds certain values. Well, you want a relief, all right? And therefore, that reduces the severity. The probability has already happened, but it reduces the severity. So you have safety devices, all right? And the safety devices are divided into two sections. One, devices that require no human input, which by far is the best. And examples of those are active, like, for instance, you look at safety interlocks, sprinklers, airbags. They're constantly monitoring the system. And if they see an excess or a limit, they deploy, all right? As opposed to passive, no active monitoring. So in other guardrails, safety nets, dikes, they're always hanging around, okay? And if anything bad happens, they're always there. There's no sensing systems involved. The next set of safety devices are not as effective because they involve we humans, all right? PPE relies on humans to wear it correctly to begin with, and of course, that's why they are not as effective as the devices that are, require no human input, right? So, but safety devices reduces both severity and probability. Warning devices only reduces the probability side. When you see a sign, wet paint, do not touch, what's the first thing we do? We touch, wet paint. So what it does is it reduces the probability of you coming in contact with the hazard. But once you come in contact with the hazard, it does nothing to reduce the severity or drop the severity. Okay. Then you have procedures and training. They work on both. So let's take an example as fire. Fire. You train on having good housekeeping, making sure that you don't have flammables around, things like that. That's training, right? To make sure that, hey, the chances of fire happening in the first place are reduced. So it's working on the probability side. Then let's say something, you don't follow procedures, or there is a fire that takes place. Well, then you're trained on how to evacuate, emergency evacuation. So that prevents the severity. So in other words, prevents you from getting burned up or serious injuries and things like that. All right. So evacuating does nothing to do to prevent the hazard. The hazard has already taken place. It just prevents or reduces your severity. So that's how procedures and training can work on both sides of the equation. PPE reduces only the severity. Because, for instance, and let's say gloves, if you're titrating an exothermic reaction, water and acid, or in chemistry labs or in any other labs, for instance, right? And there's an excess, the reaction goes to out of control and it starts spilling, all right? And it lands on your hands, let's say, the gloves reduce the severity of the burns, or you may get no burns at all. But the gloves don't prevent the exothermic reactions on the spills from occurring in the first place. Just works on the severity side of the house. All right. Yeah. It reduces the severity, assuming the probability, and of course, insurance reduces only severity. So you pay, whenever let's say you have the right kinds of insurance. Make sure, by the way, you have flood insurance. The hurricane season is coming, so make sure you check your flood insurance is there. All right, because there's a 1 month gap between when you register for your flood insurance and actually kicks in. So please use that to keep in mind. That take your notes and say, hey, I need flood insurance. Okay, if you're living in those danger zones, right? All right. And then, of course, insurance risk reduces the severity side of the house. So they pay for the losses, allegedly, all right, if your insurance is good. But still remember, there's your copay and there's certain minimum that you have to pay. That's known as residual risk, all right, which you have to eat and swallow. Countermeasure selection, how much effectiveness in terms of how much of risk reduction that you remove, is it value added? Keep that in mind. I'll be doing things that are value added. And not just talking about countermeasures over here for your business as an employee. Are you doing things that are value added? Are you contributing to the business? Don't tell me how long you spent doing it. Tell me what you actually did. All right. So effectiveness, how much risk reduction, shall we say? And there's feasibility. Is it technically feasible? Technology is improving all the time. Can we use newer technology? At what cost? Then we get into the delivery and availability. There are events in the world today that can affect this. You talk about supply chain. It was affected by COVID previously. Now it's getting affected by wars. So there are so many issues that can affect delivery and availability. All right. So keep that in mind. Implementation time. How long does it take to do the countermeasure? Remember, we're looking countermeasure selection. It doesn't introduce new hazards. So for instance, if you're trying to guard an ogre or using a guard, or you're doing machine guarding and all of these fancy things, if the guards themselves create hazards like sharp edges or whatever, then that becomes a problem. So you got to understand that when you're trying to protect one hazard, guard against one hazard, you don't introduce another hazard. Lubricant flammability. If you're looking at selecting a lubricant that offers a better coefficient of friction, for instance, right? It might be great on the coefficient of friction from the coefficient of friction standpoint, but it can have a higher flammability level, right? And might cause a fire hazard. So you got to keep that in mind. Remember, whatever you do in your own domain of work, you got to understand how it affects the other aspect of the business. It's part of systems thinking, all right? How do you integrate whatever you're doing into the rest of the business or understand how it affects the rest of the business. All right. These are the countermeasure selections. And of course, finally, making sure that it doesn't compromise system performance. So if a machine that needs oiling, all right, you don't necessarily want to stop the process down, remove the guard to do the oiling. You want to be able to do it in process, right? Without hampering production. Well, you might have opening ports or grates or whatever where you can introduce your oil or lubricants in process, all right, without having to stop the process or remove the guards, because once guards gets removed, trying to put them back on again can be an issue, as you would know operationally from the folks that are present, all right, in your businesses. So that's what we're looking at. And now I'm going to turn this over to my colleague, Mr. Mfinger. Okay.
Thank you, Dr. Rodriguez. So we're going to continue with identifying common workplace hazards and the techniques that can be used. As earlier, Dr. Rodriguez talked about JHAs, JSAs, RWLs. So, and then in these workplace inspections are some things that you can use to help near miss reporting, other documents, your OSHA logs, near miss, employee involvement. You want to definitely involve your employees in helping you with this. So assessment techniques, job hazard analysis is just one of them. And sometimes people refer to them as JSAs, which are job safety analysis, but they're kind of similar in a lot of aspects. And why do they matter? Why does a job hazard analysis in the workplace matters? It matters because failure to identify or recognize hazards in the workplace can lead to injuries and illnesses. And that's going to cost the company financial money. It's going to have employees injured, and that's what you don't want in your workplace. And what do you need to know? All workplaces have job hazards. They all do. Some are more severe than others. Um, so, and then how to implement controls. Those are things that you need to know when you're doing a job hazard analysis. You want to look for these things. You want elimination of the hazard, substitution of the hazard. And engineering controls can be a way. Administrative controls. Maybe, you have training that informs the employees about ways of preventing an injury. And these are all the things that you can use. And when you want to do your job hazard analysis, you want to gather a team together. You want to identify jobs that are candidates for JHAs, welding, forklifts. They're all part of these jobs that will have injuries. Decide how you record the results and establish a process to follow up and address the hazards and identify. So the critical element of any effective job and health program is a proactive, ongoing process to identify and assess hazards and hazard situations in both commonly performed jobs and non-routine jobs. So here's a job hazard analysis that has to do with lifting flour bags. And again, that's where you're going to use your recommended weight limit, the analysis to determine an employee manually lifting a 40-pound bag one at a time from a pallet. Repetitive motion and stress on the lower back is an ergonomic hazard. So ways to correct this, control it, are adjusting the lift table. Maybe you need 2 persons lifting or frequent breaks. And another thing that's not on here is introducing robotic controls, a machine that is doing the lifting for you. You do the analysis and you may figure out that purchasing the machine in the long run is going to be more feasible than having the person doing it and risking an injury. So these are just ways that you can do in your plant to perform this analysis. And workplace inspections. That's where you would have the employees involved. They would walk through the plant, sometimes daily. Each employee will inspect his work site daily, looking for hazards. If they're using extension cords in their workplace, they want to inspect those cords daily to make sure they're not frayed or the ground pins are not broken, which could cause a hazard. They do monthly inspections and yearly. Fire extinguishers, you have to do a monthly visual inspection of your fire extinguishers. And then you have to have them maintained yearly by an agency to make sure that they're properly maintained. And that's where you want to include your employees in the inspection, because if they feel like they have involvement, they will put more effort into it. Document and review the inspections. Make sure they're just not doing them and putting them in a drawer. Make sure you review them and go over them. You know, have talks and meetings and go over it with the other employees, supervisors. Make it part of your workplace. Make it common, because if you do it routinely, then it becomes the norm, and everyone is more involved, and it's less likely for accidents and incidents to happen. So near miss reporting. Encourage your employees to report all near miss incidents and injuries, because it's not that you're worried about them getting in trouble for reporting something, an injury. You want them to report it and say, hey, I was doing this and this machine almost caught my finger. Well, maybe you need to inspect the machine and see if something's wrong with it. Maybe the guard is giving out the mechanism that releases the lid. Review all near miss incidents and injuries. Same way. If you don't review it, you won't remember or go back to it, and you may miss it, and then an injury could occur. And share these findings with all the employees and compare it to your 300 logs. If you see a lot of back strains on your 300 logs, then there could be a problem, because most likely there is a problem if you see a lot of them. So you would want to review that. If you see people's fingers getting cut or anything like that, you want to review that, so that way you can correct a problem before someone gets seriously injured. Again, employee involvement. Encourage your employees to be part of the safety committee. Continue to allow employee input. Sometimes suggestion boxes. You can put those up and people can put comments in a suggestion box. Build a culture for safety with the employees. That way, once they learn how to recognize hazards in the workplace, it's going to become common to them and they're going to see them. So risk assessments for the job functions. This is just another way, and every job is different. These are just some functions: welding, grinding, and cutting, spray painting, cleaning and polishing, mobile equipment operations, and then other office staff. Even the office staff that may just walk through the plant, they need to know what hazards are in the plant, because if they don't know to wear the hard hat and they walk out there and something falls off on their head, they're going to get injured. So it's all about training. And when you look at the risk, high risk for welding, grinding, and cutting, because you have lots of different risk involved in this job. You have burns, you have sparks flying from grinding and cutting. You have to have the protection shields up when they're walking by, because people can get injured by the flashes of a welding rod that could harm their eyes. So we got the risk score and probability, severity, and exposure time. And as Dr. Rodriguez mentioned earlier, you would calculate all this in your plant, and each industry could have different ways of the way they want to calculate this. And there's many platforms out there for employees to calculate their values. We got probability. Is it rare, unlikely, possible, likely, or very likely? And then you have a total score of 5, because you have it ranked 1 through 5. And then how severe is it? What's the severity? Is it minor injury, Is it medical treatment, lost time, permanent injury, and fatality, which could equal to a 5 also for the major fatality. And then you have exposure, which is exposure time. A person working in a noisy area, the longer he's exposed to that noise, the more likelihood he could have damage to the hearing. So is it rare exposure, occasional? Rare could be like an office employee walking through a plant without his safety glasses on and someone's grinding and a piece of metal flies up and hits them in the eye. That could be a rare one, but you want to look at that. You want to look at all of them. Occasional, weekly, daily, and constant exposure. A person that's welding every day for 8 hours a day, they're going to be at the top ranked exposure. And then you calculate and you total your scores, and you could come up with a score of 125 because of the multiplication of the different exposures. And some of these risk charts have a 5x5 chart. You'll see most of them. They'll have 5x5, but this one is 5x5x5 because we added the extra exposure time just so we could see the difference. And here again, we have 25 employees exposed, and they're exposed to burns, flying particles, noise, hand injuries, and hexavalent chromium exposure. And then, the probability would be a 4, the severity would be a 4, and the exposure would be a 5 because he's working in it for all day long. And the calculated risk of the probabilities, the severity, and exposure equal to 80 out of 125. So that's very high, is the risk level. So in order to reduce some of this, for instance, if a person was using burns, for example, if they wore their proper protective gloves, long sleeve shirts, welding hats or jackets, that could reduce the probability. It could reduce the severity. The exposure time is still there because he's doing it all day, but it could actually reduce this probability and severity. I mean, maybe this exposure, because he has the jacket, he's not going to be exposed to the burn, but he's still spending time there. Even for hexavalent chromium, there's other eliminations. You could use different types of welding rods, flux rods, different things to eliminate the exposure to the hexavalent chromium. You could introduce engineering controls where you have ventilation in place. So the ventilation is removing all the harmful fumes from the workplace. And that could help do that. Administrative controls, there's different types of controls you can introduce to reduce the methods. And then here we have painting, cleaning, polishing, and stainless steel. The estimated ratings, probability is a 3, severity a 3, and exposure a 3. So we have 27 out of 125. So this is a medium risk. And it could even be dropped lower based on, wearing the proper PPE. And that's where you would do the HAZARD communication program where you're training your employees on proper PPE use, the chemicals of exposure. They're not going to be exposed or likely to get burned by a chemical if they have the proper PPE on. Respiratory irritation, chemical contact, same way. If they're wearing the right gloves, you're going to be able to reduce this number and get down into the green earlier, like Dr. Rodriguez was showing you. That's where you want to be. Now, it's not saying that they won't ever get injured because their gloves could tear by accident. They could catch them on something and then they could get injured, but it's going to lower your number. And that's what you're looking for. You want to get that number as low as possible. Mobile equipment operators. Again, this is a different job and it could be equipment rollover, struck by incidents, collisions. And here is, again, it's a high risk because the probability of equipment, someone getting hit. They have forklifts now that have lots of different safety devices on them. They have lights that radiate out from the forklift about 4 feet on each side, and it's a blue light. So when you see the blue light, if you're in that zone of the blue light, it's a likelihood you could get struck by because you're close in contact with the forklift. There's lots of different controls you can use to help you. And then other personnel in the office. Again, it's really low, but if you're walking through the plant and somebody leaves a extension cord out in the hallway, that could cause a slip and a trip. Or if they're out there and someone's grinding, like again, medical, minor electrical hazards. They pick up a cord and it has a cut in it because the cord didn't get inspected daily. That's why you want to introduce employees, workstations, inspections daily. So we have the employee risk distribution here. Again, we did it based off of 50 total employees in the plant, and 25 employees has a high risk, very high risk, and then 5 employees has a high risk. So you got, 80% of the people out of 125 is 80% risk, and then so you want to try to eliminate these high risk incidents in the workplace. The risk levels, you want to get them down as low as possible. Again, here's one from burn risk matrix. Again, if probability, severity, and exposure, and it's likely, and then this is wearing no PPE, and it puts you at a very high risk. And then if you're wearing a PPE, it's unlikely that you would be injured as bad. So it reduces your risk by 70% here because of wearing PPE. It's going to protect you from those injuries. Immediate danger, unacceptable risk, because you want to make sure that they're wearing their PPE and improve safety in the workplace. And then we have some OSHA standards that we're going to use in the workplace. Most general industry standards are going to be 1910. And in construction industry, if you're in there, it will be 1926. And then we have maritime shipyards are going to be the 1915, 17, 18, and 19. But employers must provide a workplace free from recognized hazards. Because if not, if OSHA comes into your workplace and there's not a standard that says that there's a hazard there, but they recognize that there is a hazard, they're going to write you up under the general duty clause. And they're going to say you did not follow the manufacturer's guidelines for preventing that hazard. For instance, a person using a chainsaw. Okay, it's slow at work, so you wanted Joe to go outside and cut a tree down. And you tell Joe, get the chainsaw out of the maintenance shop and go cut the tree down. Well, Joe cuts the tree down, OSHA drives up and sees him using the chainsaw without the proper PPE on. Well, they're going to write you up as a General Duty Clause 5A1 because you didn't follow the manufacturer's guidelines of the chainsaw. And it says you must wear a hard hat, safety glasses, face shield, chaps, and leather gloves. And that's what they're going to cite you under because you didn't follow the manufacturer's guidelines. So you must know what hazards are out there and how to decide, do your job hazard analysis to prevent any injuries. And here are just a list of some of the frequently cited standards in OSHA. And you can see fall is one of the top ones. And there's many others, and they're pretty much similar in both industries of general industry and in construction. So in conclusion with that, hazard recognition prevents hazards and reduces the risk that contributes to injuries. That's the main thing that you want to do. You want to look for that. And anyone and everyone can learn to recognize hazards in the workplace. Report hazards immediately, regardless of the severity. You may not think it's that severe, but it could turn into severe if someone injures themselves. Continuous improvements is the key to a safe workplace. That's where those job site inspections are going to come in handy. You do it, walk through your facility, and you identify because shortcuts cuts life short. That's a phrase that I've heard from someone, I'm not sure, but it is so true because many times when you take that little shortcut, you can get injured. You can't reach, you're up on a scissor lift and you can't reach the top of the ceiling, so you stand on the guardrail and then you slip and fall and get injured. So, the summary of the objectives mentioned today for the fundamentals of risk assessment, the qualitative methods of evaluating job-related risk, the overview of physical, chemical, biological, and ergonomic hazards, using sample job scenarios to rank workplace risk, strategies for applying risk levels to safety decision making. And in that, anytime you have questions, just give us a call. We'll be glad to talk to you over the phone. But this is here. We're free. We're confidential, and we're out there if you need us. So now I'm going to turn it over to our moderator, Alex, and he's going to open up the floor for questions that are out there. Thank you.
Thank you so much for that, Marilyn, Dr. Rodriguez. That was very insightful, very informational. Really, really enjoyed the presentation. So we're going to move into our question and answer portion of this webinar. So if anyone has any questions, please do put it in our Q&A chat so that they can be answered. So we're going to go ahead and go into our questions. So we did have some questions pre-webinar from some of the attendees. And so these are some to just kind of kick us off. So the first question is, do you have any software recommendations for RA, HAZID, and JHA?
Well, yeah, let me take this one right here. When hazard, I would imagine that's what the intent was, RA. Yes, there's lots of software out there, a lot of companies, both free, paid and free, that offer services. It all depends essentially on what you're looking for, what type of operation you're trying to analyze. And so we've covered a few that we mentioned, but there's a lot of free software available, as well as companies that will, through consulting services or with other hardware that they offer, would in fact offer computerized versions of a lot of these techniques, depending on your need, as I say. But mostly, if you could use a straightforward Excel sheet, for instance, for most of what you want to do, especially if you want to do a JHA, even a hazard. I've even done, for your FMECAs and PHA analysis. You can use your Excel sheets, most conveniently available, used for other things, and yeah, you could use it. But of course, there are certain specialized software that sometimes from the University of Michigan, the 2D static strength model, or Aaron Garg's expenditure, energy expenditure models, or Liberty Mutual software or tables are available for free. But there's a lot of free stuff available out there. Bottom line is, it all depends on what exactly do you want to do. What's your job? What issues are you trying to address? And given that, we could be of better advice to you once we know exactly what your operation is. See, so that's what I have to offer over here. Go ahead, Meryl, if you feel anything you can add to it, that's fine. But that's what I think. Yeah.
Yes. Yes, sir, Dr. Rodriguez. There's some other places also. OSHA has a website, osha.gov, and they have places in there that can help you look for some information, job hazard analysis, instructions. They have what they call the e-tools. So if you visit the
Yes.
OSHA website, again, they have lots of information that can help you with this, and that's one of the things I will mention.
In fact, that leads into the second question of aside from self-inspection tools and protocols, has USF created any other guidelines? Well, once again, depending on what your operation is, when we come out and do our inspections and then develop reports as a result of that, a lot of times we give you information based on what you need, whether it's ladder inspections, SMS system, which is Form 33. It's got 58 elements in that, and it gives you guidelines on how to address those issues. So we cover a lot in the either in the safety handouts that we give during our visits when we come to your facilities, and also after we finish our visits, which culminates in a confidential report that we send to the employer. We have a lot of this information included, once again, based on your needs. All right. So that's, yes, we do have that.
Okay, thank you both. Another question here is, it has been determined that 30% of Gen Z cannot identify a straight blade screwdriver. How do we get them safe work ready?
I think I'll answer this one for Dr. Rodriguez now, and he can add into it if he wants. This question is kind of one that a lot of people mention all the time about different, generations of people. And every generation has changed, even though we know our workforce has changed, even different standards and levels of safety. My thing is, employees have to provide a safe workplace for the employers have to provide a safe workplace for their employees. And the main thing is they have to train their employees. And training is one of the biggest things that helps provide a safe workplace. If you know there's a hazard, if there's a hazard dealing with the straight blade screwdriver, you have to inform your employee, regardless of what generation he's from. And once you do that, he knows how to recognize something, and then it provides a safer workplace. And that's just one of the things out there. It's all about training. It's all about identifying. And everyone can be trained. It's just they may never came across it before. And there's things out there where people will ask me, and I'm like, I never heard of that before, But once I learn about it, then I know. And then you can move on. We don't want to, and then also in the hiring process, if you're going to put a person in a hazard situation, you want to make sure that they're familiar with what hazards are going to be in the workplace, and that they understand that, and then they're willing to work in that type of situation. So you don't want to put someone in that situation if they know nothing about it. So again, Dr. Rodriguez, anything to add?
Yeah, I'd like to throw in a few cents over here. First of all, yeah, I agree when you in your last statement that when you're during the hiring process, you got to make sure that you're hiring the right individual to do the job. That's the main thing, right? So obviously, you're not going to hire someone who can't identify a straight blade screwdriver for a job that involves that, right? So yeah, it's the hiring process that you need to pay careful attention to, irrespective of the generation, because every generation thinks they are by far the best, and they always think that the next generation cannot perform as good as the current generation. We've all done that. It goes through, we go through cycles, all right? But yes, so in addition to the hiring process, but what I would also like to pick up on what Meryl said was, yes, you can train individuals, you can train and train, but you also have to have accountability with that. Training, in fact, there was a study that was done by one of the insurance companies, and which said, training can take you only so far. In fact, they went back to saying that training can only take you 1/3 of the way in solving your issues. All right. So keep that in mind. But with training comes accountability. So that also has to be in place. And accountability, consistent accountability. That's what you need to keep in place too. So whenever a zero tolerance policy that might exist, all right? that you might have, and they usually have it for violence in the workplace and some of those programs that you need to address. But accountability should also go with training. So you provide the individuals with the training and the resources needed, and then hold them accountable. That's how it should work. Yep.
Thank you both so much. We did get a couple of questions in the chat. This one is, we are a nonprofit marina and sailing club. What cost standard can be applied in risk management other than dollars, such as work days or hours lost, and if there are any suggestions?
Yeah, okay, let me see. You're talking about can be applied other than costs. Jeez, that's a new one. No, I understand that. Yeah, yeah. If you look, because if you look at even lost work days, lost hours, all of those ultimately tantamount to cost. But here's one thing that this question triggers my thought process. If there's one thing that you need to address in your company, is the culture, the safety culture. How do you address the culture? Or how do you create a culture that is good, that is successful? Because remember, you can have the culture is the difference between someone having a sore wrist, taking a few ibuprofens, and then coming back together, work the next day, or an employee having a sore wrist, but who's sort of disgruntled or not quite in the culture of the company, and then contacts a lawyer, and the next thing you know, you're going to have a carpal tunnel release, and you're going to have all kinds of litigations and workers' compensation costs and all of those issues just because of this one simple wrist inflammation that could have been solved with just ibuprofens. All right. So it's the culture that you maintain. The employees are the ones that are actually facing the music in terms of hazards, and invariably they have the solutions that come with it. All right. So it's important that you create a culture of openness wherein they can come forth with their recommendations and suggestions, and you should address them. Now, it doesn't necessarily mean that you have to fix all or take all of the recommendations that they've offered, because some can be off the wall. But it's important that you get back to them and let them know the reasons why you do not implement their recommendations, reasons for that. Of course, if you've recommended or you've done some of their recommendations, praise them, but respond why you did not. All right. So in the future, at least they'll be encouraged to bring those suggestions forward. All right. So they should be comfortable enough to do that. Minimize fear. Okay. Now there's several different ways of doing that, and safe and culture can be quite vague, but you know it when you see it, as they say it. And it's just not safety. It's the entire company culture that needs to be addressed. Because if you address it in, very often I've seen, or rather, no company is going to be excellent in quality, but suck in all the other areas of safety or delivering on productivity and things like that. They're going to be good in all areas. And to be able to be good in all areas, you need to set up a culture that is good. How will you set up? What kind of culture? It's your understanding, but keep that in mind as you progress. So that's what I have to offer in that domain.
Okay, thank you so much for that. Another question we have is, what are some ways we can get employees to think about safety without having to constantly correct them? For example, pulling extension cords across walkways or wearing hearing protection.
You want to give this a shot, Mel? Then I can always pick up the pace on this.
Well, I know some employees tend to keep doing things, but it talks about OSHA recommends that you put things in place for disciplinary action, because you have to prevent injuries in your workplace. And then that is some of the ways you have to put in place to remind them that it's important for them not to drag the extension cord across the work aisle, because you're doing something that you've been asked not to do. So you just have to start putting some type of disciplinary action in place. And eventually they're going to do it. They're going to get in compliant if they want to work at the facility. Um, that's one of the ways that's mentioned in the program for providing that. And then just find a way to take them to the side and talk to them and see maybe there's other things going on in their life that just makes them feel like they have to do that, disgruntled or whatever. So communication is a big thing. And I think that is a big culture that you have to build. And if Dr. Rodriguez like to add anything else, but that's what I see in the workplace because I've been on both sides.
Yeah. Yeah, I'd like to pick up on this. It's the carrot and stick approach. Now, to be straight up front in terms of the actual procedure, when you talk about, the 3 strikes you're out. So, for instance, the first is the verbal warning, second is the written warning, third is, time off, and then, of course, time off without pay. Uh, Structure it as long as you have a process and you apply it consistently across the board. All right, that's the procedure aspect of it, which you must have in place. Whatever your company decides to do is up to you. I just gave you an example of a phased-in process of having accountability. Now, that being said, of course, the employee has to be trained, provided the resources, and all of those things before while you implement this policy. All right, that's one issue. That's in terms of the procedural and management issue, and apply it consistently across the board. But another thing is the human issue that I like to approach. And I use this example. In fact, it was in the construction business where an employee was working on a grinder and not wearing personal protective equipment. In fact, the personal protective equipment was in the individual's pocket and they were not using it. So I called the guy aside. I said, listen, if, for instance, anything happens to you and you cannot work, you get an eye injury and you cannot work, you're going to be off the job. You don't get money. How are you going to put food on the table for your family, assuming you're the only one that is working in your family? Have you ever thought about that? All right. Forget OSHA, forget all these rules and regulations and all of these issues. That's a given. Obviously, that's not working. But think about this. Your downtime, you're not earning money. How are you going to put food on the table? All right. And of course, the individual, quickly understood that and put it on. Now, I don't know if that's going to last, but this is the kind of approach, as I say, the carrot and stick approach I would use. By the way, it's not easy. When you're running production, when you're trying to meet the numbers, you're going to have all these kinds of things going through. It's a tough thing, but it's as part of the continuous improvement process. It's a continuous thing. That's all I have to add to what Meryl just said.
I could add another part
Go for
pertaining
it.
to the PPE, the hair protection. Now, that could be a different thing than just a extension cord being drug across the aisleway. The PPE, you want to go to the employee and discuss with them and find out why he is not wearing his PPE. Now, there could be different reasons. PPE does not one size fit all. Earplugs, there's many different brands of earplugs out there for hearing protection. There's over the ear, there's in the ear, there's the foam, there's a rubber, there's different types. And maybe the type that he was issued or she was issued, the employee was issued, was not the right type for their ears because everyone's ear canal is built differently. So that's where you want to do the assessment and say, let's find something that's comfortable for you, that's going to protect your ears, and that you will wear. And that's another thing that you want to look. Because I remember working in a workplace where everybody was taking their glasses off because they were fogging up. Well, we had to go to the employee. We had to say, hey, look, we need some eye protection that's not going to fog up. And then once you did that, then everybody started wearing it. So that's another thing. You want to evaluate the PPE for the individual. And that's just one of the things that I would say with PPE. You want to evaluate it and pick out the right PPE for the person and the job.
Adding to that, in terms of PPE, I remember a case out in California where one of the plants over there, they were having the same issue of eye protection, and standard glasses were sort of these old clunky glasses, and management decided to bring in some nice designer shades that look pretty cool. And right away, everyone started using them not only on the job but off the job too. So that's, I guess, another way of trying to get them to use PPE. And of course, that's just one of the things that was mentioned over here. The others, the extension cords, walkways. But another thing I'd like to be able to add is that when you do, if let's say an accident takes place or a near miss, you do an accident investigation, a root cause analysis of determining what the issue is. And once you determine what the root cause is, and of course, there may not be just one root cause, but a series of root causes, then you can attempt to determine how will fix it in the future. Sometimes it could be a fault in the system. It could be, taking shortcuts. Why are they taking shortcuts? Maybe the shortcut is the most efficient way of doing it. All right. So we might want to take a look at those things in terms of pulling the extended wire cords pulled across the walkways. Maybe the orientation of the operation is not quite right, because a lot of times a facility or an operational line will be designed for a certain product and a certain production of a certain product. But then the line might change to produce another product, and there might be a shift and a change in the orientation, but it might affect other areas of connections and things like that. It's part of systems thinking. So you've got to make sure that why was the extension cord pulled across the walkway in the first place? All right. What is the root cause of that? And try to fix all of those. So it's either operationally, design, or procedures to the human or the equipment. So you got to determine where the issue is and fix it. If it's on the operation, on the equipment side, well, you might want to redesign, re-engineer that. If it's on the human side, well, there's procedures and accountability and training. Yeah.
Yeah, and Dr. Rodriguez, you brought up a great point. In the Form 33, it mentions about companies' workplace when they change the work design, they have to do another assessment after they moved equipment around to make sure that they didn't create new hazards when they redesigned the plant. And like you said, they moved the machine around and they didn't realize they needed power to that side of the machine. So now that's why they're running the cord. Yeah. So that's another thing that the company would want to do, would be do an analysis of the workplace. And that's talks about that in the Form 33 when we do our assessment for companies.
Thank you both for that. Our last question is, I work for the county. I would like to know how to go about doing the JHA for hearing testing. Last time JHA were conducted was in 2000, and they were tasked with redoing over 600 JHA. Any suggestions for hearing testing?
Well, I guess which county are they in, or is Dr. Rodriguez, would that be somebody that we could come in and work with?
Well, yeah, we could determine. I'm trying to understand the question over here. JHA for hearing testing. I mean, hearing testing, there's a protocol what one has to follow, so that's pretty straightforward. And then the JHA was conducted in 2000. It starts to do over 600 JHAs. That's a lot of JHAs, and that's job security there, right there. But yeah, you can keep it simple. In fact, instead of you trying to do it, now, by the way, the ideal would be for us to come in and take a look at what you're trying to say, or maybe have a follow-up conversation on exactly what you're looking at or what you intend to do. But if you're trying to do 600 JHAs, job hazard analyses, it's better that you form a committee and team together of employees who are actually doing the job, right? And get them involved. That way it'll be more effective. It'll be more value added for you rather than you trying to do it, because you're going to have to, because if there are so many different types of jobs, you might not be aware of all the jobs that are taking place. Only the individuals doing it will know it. So I suggest you start off by forming a committee or a team or whatever to be able to address it, and then progress, phase it in terms of what jobs you must do, in terms of phasing in the jobs, what are most important jobs that you need to do first, the first maybe top 50 or top 30, what do you need to do first? The high risk jobs, remember we talked about risk. How do you determine the high risk jobs? Well, where's your liability? Where's your costs? Where's your workers' comp? Where are individuals taking time out, or there's injuries or illnesses or whatever? Try and rank which jobs you will do first before you continue doing that. You see, we need to know more about exactly, and we can talk offline. You can contact either Dr. Merrill or myself, or and we can find offer you more advice. So I think this is the kind of approach that we would like to, that at least I can offer as of right now, from what I'm thinking. What do you say, Merrill? You have any other thoughts on this?
Yeah, the thing that I'm when you're in a job place and you first want to do hearing testing and sampling for the job location to look for noises that are above the levels. And once you decide and determine based on sampling results that you're below the permissible exposure limit, and you really don't have to come back and redo the testing for that job unless you change some type of process that would cause the noise to be increased. Correct me if I'm wrong, Dr. Rodriguez, but once you determine that this piece of equipment is below the hearing conservation levels, then you don't have to retest that job again unless you change some kind of process. You can use your results and then do your program based off of the results that you received. If you were at 90 decibels, then you would wear hearing protection and you would have a hearing conservation program, right?
Yeah, I mean, you would do all of that stuff. I mean, you're not testing the equipment per se. I mean, yeah, but you're testing the sound that emits from the equipment. You're using, area sampling and noise levels. Yeah, what you said, you may not need, hearing protection or to begin with, but that's the root cause to determine if you need that in the first place. And as I said, till we know more about what you're actually trying to achieve and do, this is all what we can offer, because I don't know if it's about the hearing testing per se, but that's a standard procedure. The question, do you need to do the testing in the first place if you don't have any noise? So that's what you first have to determine. And then you can do a JHA on the job that doesn't necessarily involve hearing. There are other aspects of the job that could be hazardous or risky rather than just being exposed to noise. You see, so it could be a combination of both. So just for the sake of doing a JHA because we have to do it is one thing. Trying to do something that's value added is quite another. All right, and especially when you look at the number of JHA that you have to do, it requires some thinking. As I said, the more we know, the better help we can be of. Yeah. So you got our contact numbers, and you can email us, and do what you have to do that.
Thank you guys both so much again for the information in the webinar as well as our Q&A. So we're going to go ahead and pass it back to Talia to wrap us up for this presentation. Thank you so much.
Thank you, Alex. And a big thank you to all of our presenters and all of you for joining us for today's General Safety and Health Risks webinar. We appreciate your time and participation. The contact information for our presenters is now on screen and will also be sent to you via email. We have added a brief survey in the chat as well as in the Q&A panel, so please take a moment to complete it. Your feedback helps us to improve and deliver valuable content to you all. As a reminder, the presentation slides and webinar recording will be emailed to you within 3 to 5 business days. And this concludes today's presentation. Thank you again for being with us. We hope to see you again in the future.
Thank you. Have a great rest of the day. Over and out.
Thank you.